Everyone, welcome to part 2. So today we're going to talk about the algebra section of the PERT test, which is going to be about 35 to 40% of the test. And we're going to start with solving linear and quadratic equations. So we'll go ahead and start with linear equations because we've already done quite a bit of that. But just in case we need a refresher, we'll start with subtracting 5. We have 3x equals 15. 5 by 3, x equals 5. And for this one, we'll add 4. And then we'll divide by 2/3. So that means x will equal 12 times 2/3, because we flipped the fraction. Now we can simplify this. So x equals 8. So you'll need to memorize the quadratic formula because we can either solve quadratic equations by factoring, which is the easiest, completing the square, which I would say is the next easiest, and then using the quadratic formula. Okay, so we can start with factoring. So when you factor, we take the last constant, and we want two numbers that will multiply to this constant and add to this constant. And remember to consider the sign. We have a negative here. So let's try 2 and 3. Make them both negative, because -2 times -3 equals 6. And -2 plus -3 equals -5. So there we go. So then we'll have x minus 2 times x minus 3 equals 0. So x equals 2 and x equals 3. Now, this one can be solved using factoring, but we're going to go ahead and do the quadratic formula on it. But just to make sure we get the right numbers, let's go ahead and factor it. So we have x squared plus 4x minus 5. We have our -5. So this one will be 5 and 1, and we'll make this one negative. So we have 5 times -1 equals -5, and 5 minus 1 equals 4. So we'll have x minus 1 and x plus 5 equals 0. X equals 1 and x equals -5. So now let's put that into the quadratic formula. Usually you use this when the equations are not factorable. Okay, so our quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So filling this in, we have x equals, and these a, b's, and c's come from this, ax squared plus bx plus c equals 0. And we've got a 0 on this side of the equation. So our a, we just have a 1. Our b, we have a 4. And our c, we have a -5. So we'll say -4 plus or minus 4 squared minus 4 times 1 times -5 divided by 2 times 1. And we have x equals -4 plus or minus 16 plus 20 divided by 2. We have x equals -4 plus or minus 16 times 20 is 36, and the square root of 36 is 6 divided by 2. And then reducing this, we'll have 2, 3. So x equals -2 plus or minus 3. So x equals -2 plus 3, -2 minus 3. So x equals 1 and -5, which is what we have up here. So we are correct. And last, we can solve by completing the square. So when we have completing the square, we want to get our equation x squared plus 6x minus 7 equals 0 into this form, x squared plus ax equals c. So we want our constant on the other side of the equation. So we'll say x squared plus 6x equals 7. And then we want to take this a, and we want to say a divided by 2 squared. And if you forget this, it's okay, because when we go back and check, it won't work out. So this is our a. So we'll say 6 divided by 2 squared, which equals 3 squared equals 9. And we want to add this to both sides of the equation, this 9. So we'll say x squared plus 6x plus 9 equals 7 plus 9, which is 16. So we have x squared plus 6x plus 9 equals 16. And we can factor this side of the equation. So we have 9 multiplying 3 times 3 equals 9. And adding them equals 6. So we say x plus 3 squared equals 16. And this is what we mean by completing the square. So we'll square each side, and we'll have x plus 3 equals plus or minus 4. Now we can subtract 3. We have x equals plus or minus 4 minus 3. So we have x equals 4 minus 3 and -4 minus 3. So x equals 1 and x equals -7. And if we want to check this, remember we have to go back. If we want to check this, we have to go back to this form. So when we multiply it out, we would say x minus 1 times x plus 7. So that would be x squared plus 7x minus 7, which, let's see, which then would equal, let's move this up. Which then would equal x squared plus 6x minus 7, which is what we have up here. All right, so next, let's see. We'll go to graphing coordinates and linear equations. So when we're graphing points, we start with the first coordinate, and this is the x coordinate, and this is the y coordinate. So we'll go over 1, 2, and up 1, 2, 3. And this is A. And next, we'll go over -1 and down 1, 2, 3, 4. -4. And last, we have 4, -2. So we'll go over 4, 1, 2, 3, 4. Then we'll go down 2, 1, 2. When we graph lines, so remember this is the x-axis is where we'll be plotting this point, and it's equal to -3. So we put the point on the x-axis because we're plotting x. And then we'll just draw a line straight through it. And for this one, we're plotting y equals 4. So we'll be on the y-axis, which will be, can move this. So we'll be here, so that's 4. And it will be a horizontal line. Now, when we're plotting linear equations, we have the form y equals mx plus b. This is going to be our y-intercept, which means we'll plot this point basically like we did here. Will be there. So for this one, we have a 1. So our y-intercept is going to be a 1. So we can go ahead and plot a point there. And then this is our slope. And in this case, it equals 2, which also equals 2 over 1, which means we're going to go from our y-intercept, and we're going to go up 2 and over 1. We'll go down 2 and up back 1, down 2 and back 1. And you can remember this as rise over run. And last, when we're plotting quadratic equations, you could always do this just by filling in numbers for x. But again, we will use this as our y-intercept. So we'll go down here. And then when we have x squared minus 4, that's going to equal x plus 2, x minus 2. We can check that by saying x squared minus 2x plus 2x minus 4. And that does equal x squared minus 4. So then, if we have 0 put in for x, so we're on our x-axis, it will equal 2 and -2. And there we go. Next, we're going to look at polynomials, subtracting, adding, multiplying, and factoring. All right. So first we'll add two polynomials. So we'll say 3x squared plus 2x minus 4 plus 5x squared minus 3x plus 7. That will be 3 -x and 8x squared. 4x squared plus 5x minus 6. minus 2x squared minus 3x plus 1. So we can go ahead and change the sign of all of these bottom ones. So we'll say plus, and then we'll add a negative here, positive, and change this to negative. So that will be negative 7 plus 8x, and that will be 2x squared. Next, if we want to FOIL it out, as in multiply these two polynomials, we first say we can write out our equation, 2x plus 3, x minus 4. So FOIL stands for first, outer, inner, last. So we'll say FOIL first, that will be 2x squared, outer, minus 8x, inner, plus 3x, and outer, minus 12. So we'll have 2x squared minus 5x minus 12. And if we want to factor a polynomial, we've already sort of gone over this, but we'll go ahead and do it one more time. We have 10, we'll do 5 and 2. We multiply these numbers to get 10. We add them to get 7. So we can say x plus 5, x plus 2 equals 0. So that means x equals negative 5 and x equals negative 2. And to factor one like this, we can take out a 3x because that is their common factor. So taking out 3x out of 6x squared, that gives 2x plus 3. Now, if we want to solve some systems of equations, that means we're solving for x and y. And there's two ways to do that: substitution and elimination. So for substitution, you'll solve for one variable and plug it into the other equation. And for elimination, you'll eliminate one variable and solve for the other. So let's start with elimination. So we have 2x plus 3y equals 12. And 4x minus 3y equals 8. And since we have these two here, we can see that if we add these two equations together, those will disappear. So we'll only be left with 6x equals 12 plus 8, 20. And then dividing this, we get x equals, so we have x equals 10 thirds. And then we'll put that back into one of the equations to find y. So we have 2 times 10 thirds plus 3y equals 12. So then we have 3y equals 3 times 12 is 36. Minus 20. So then we'll divide by 3, divide by 3. So we have y equals 16 over 3 times 1 over 3. Yes, okay. So that equals 16 over 9. And that is non-reducible. There we go. Next, we can use substitution, where we solve for one variable and plug it into another equation. So here, we already have the equation solved for one variable. So now we'll just go ahead and plug it into this one. So we have 3x plus 2x plus 3 equals 11. So that will be 5x plus 3 equals 11 minus 3. 5x equals 8. So x equals 8/5. Then we can plug that back in for y, or plug in x in this equation. Plus 3. So that will be I will say that will be 31/5. And that is also non-reducible. Next, we can look at rational expressions, solving equations with fractions, which we've already done quite a bit of that in this video and in the previous video. So I think I'm just going to leave it at that. So instead we can look at radicals or square roots. So it would be beneficial to memorize at least the first 12 squares, but of course you don't have to. You can just multiply it out like regular if you need to. So simplifying this first one, we know that the square root of 36 equals 6. But the square root of 50, we're going to have to divide this up. So we have 25, that's a square root here, times 2 equals 50. So instead, we can write this as 5 times the square root of 2. And we want to reduce it down as much as possible to where this cannot be broken down at all in order to take out a square root. But if we want to solve an equation with square roots in it, we can square each side, meaning that x equals 64. And squaring each side of this equation, we have x plus 7 equals 25 minus 7. Let's see. 18. And squaring each side of this. 2x plus 3 equals 49 minus 3. 46. Squaring each side of this equation, we have x plus 4 equals 2x plus 3. X equals, or x plus 1 equals 2x. There we go. If we want to check this one might be one that you would want to check. That is correct. Now, if we have s squared equals 64, we can square root each side, meaning that s equals 8. And last, for this section, we can look at exponents and scientific notation. So up here to the left, we have our exponent rules. So when we're multiplying two numbers that are the same, risen to an exponent, you add the exponents. If you're dividing two numbers that are the same, that are risen to an exponent, you subtract the exponents. If you are raising a number to a power and then raising the whole thing to a power, you multiply the exponents. And if you have a number that is risen to a negative exponent, you make a fraction with a 1 on top and the number risen to the positive exponent. So we'll go ahead and work with some of these before we go to scientific notation. So for this first one, we have a to the m times a to the n, and that means we are going to add these exponents. So we have 3 to the 4 plus 2 equals 3 to the 6th equals, and if you multiply that out, it will be 729. And then we have another one where we're dividing. So that's going to be a over m, or a to the m, a to the n. So we're going to have 5 to the 3 minus 5, which means we have 5 to the negative 2, which means we're going to have 1 over 5 squared, which is 1 over 25. Now for this one, we have a to the m to the nth equals a to the m times n equals 2 to the 3 times 4 equals 2 to the 12th. Multiplying that out, we've got is 4,096. So scientific notation, remembering that when we divide by 10, we move the decimal forward to make the number smaller. And if we're multiplying by 10, we move the decimal back to make the number larger. We have some examples right here. So 10 times 10 is 10 to the squared, and 100 equals 10 to the squared. So we have 2, 2. 5 divided by 100 is 0.05 because we move our decimal forward forward 2 places because we're dividing by 2 zeros. So if we want to convert 52,000 to scientific notation, we want the decimal to be in front or behind the first digit. Like we only want one number in front of the decimal. So then we're going to say times 10. So if our decimal's here, we're going to have to move it this way. 1, 2, 3, 4 to the 4th. And it's positive because we're making this number larger. And if we want to convert 4.2 times 10 to the 6th to standard form, we're going to move 4.2, 1, 2, 3, 4, 5, 6 places. So that means we'll have this many zeros. And if we want to convert this one to standard form, we'll have 3.5 and we'll move the decimal forward 3 places. So 0.0035. Now with these ones over here, we can multiply these two and then times it by multiplying these two. So we'll have 2.5 times 4 and 10 to the third times 10 to the second. Let's see, so 2.5 times 4 is 10, and 10 to the 3 plus 2 equals 10 to the 5th. So we'll have 10 times 10 to the 5th, which equals 10 to the 6th. And we can just leave it like that, or we can say 1 times 10 to the 6th if we want it to be in scientific notation. Next, we can do the same kind of idea with this one right here. So we can say 6 divided by 2 is 3 times 10 to the 8 minus 4 fourth, which equals 30,000.